And we will now proceed to our first session. I would like to ask to come up as a moderator, the Deputy Head of the Institute of Material Science, named after Frantsevich, Academician of Academic Sciences, Mr. Andriy Ragulya.
Good morning, ladies and gentlemen. Let me speak English during this meeting because we have online translation.
Я буду говорити англійською, оскільки у нас іде онлайн-трансляція через інтернет, і багато будуть слухати наші презентації. Скажу декілька слів про стан нанотехнологій у світі сьогодні. Компанія Flux, одна з провідних таких організацій в Європі, їхні студії показують, що глобальний ринок нанотехнологій сьогодні досяг більше 300 мільярдів доларів, і очікувано, що він зросте до 1,5 трильйона доларів найближчими роками. Отже, зростання ринку дуже швидко відбувається. Нам треба бути швидкими і розумними, щоб вчасно займати позиції на ринку. Отже, ця зустріч, яку ми сьогодні влаштовуємо, якраз призначається для того, щоб подумати і поговорити про те, що треба і можна зробити на платформі нанотехнологій. Моя перша презентація, перейду якраз в неї, присвячена 10-річній роботі по багатошарових керамічних
I wanted to say, if you open your computer and cell phone from the back door,
деталі. Я хочу... От ви можете відкрити свій комп'ютер вдома, і ви побачите материнську плату, і на ній конденсатори. Моя презентація про керамічні конденсатори.
You will find green motherboard and some small cubics mounted on the motherboard. These are multilayer capacitors. Usually they are prepared from dielectrics and metals, and they on service to maintain stable fitting by electricity of capacitor of integral microscheme. The capacitor consists of layers of nickel and ceramics, and the main trend in business today is miniaturization. We wanted to have many functions inside our computers and cell phones to get more from these gadgets. So, revolutionary step in 2013, this year, we expected 100 nanometers of dielectric thickness. So this trend allows substantial improvement of electronic gadgets. And for the behavior and technology of these devices is very important for today. We have to produce 25 nanometers particle size of barium titanate, then solve the problem of colloidal manufacturing of green dielectric and electrode layers, and then provide the sintering technologies which is helpful to maintain 100 nanometer size and smaller in sintered ceramics and electrodes. What we can do on this matter, first, we have developed new technology to produce nanoparticles of barium titanate. So you can see the pilot scale furnaces producing of these nanoparticles on the level of 25 to 30 tons a year. We control atmosphere inside, and therefore we can flexibly control particle size distribution and switch from one precursor to another one and develop smaller and smaller particles for future capacitors. We have developed new processes of colloidal forming, so called tape casting and inkjet printing technologies, which are helpful to substantially decrease the thickness of green sheets from these nanoparticles. You can see thickness less than 1 micrometer. After sintering, this layer transforms to 100 nanometers thick dielectric films. Therefore, we achieved already the task. And finally, we're enabled to sinter this ceramics, maintaining very small grain size, and found proper regime of sintering to get layers of electrodes and dielectrics defectless.
Quite expensive materials for electrodes. Value proposition we have. These are technology supports future trends, allowing new advanced electronic devices, and our product hold distinctive technical features to meet the demand of continuous innovation in the passive electronic industry worldwide. Market. Today, most active development is focused on the series of 01005 series, the smallest capacitors in the world. They promise to acquire approximately 10,000 tons of barium titanate powder, and we are prepared to produce such amount very soon, and takes the segment of market almost $1 billion. We are in competition against mostly Japanese companies. They are listed here, such as Kyocera, Yuden, and TDK. So they produce more than 70% of capacitors in the world. But our focus is on production of nanoparticles. It should take $200 million, and commercialization of colloidal technologies for preparation of capacitors. For the first step, we need to commercialize and to push production of nanoparticles of barium titanate on the level of 30 tons per year. We need approximately $2.2 million and to build the semi-automated production of 021 and 01005 series of base metal electrodes, multilayer ceramic capacitors. We need approximately 18 million to develop a new enterprise producing these devices. Thank you for listening. Thank you very much for your attention. Any questions? If I am yeah, please.
Can you compare the parameters of your capacity? The best one in the world. No comparison was in your talk.
Yeah, I know. We're trying to maintain the same parameters of capacitance. So I showed that these capacitors correspond to X7R standard and Wi-Fi V standard, and we're able to produce a broad gamma of capacitors, the same like Japanese, with the same nominals, I mean, from 1 nanofarad up to 3 microfarad. These are standard. Depends on number of layers inside. Therefore, I do not compare with the standard devices here my own. We are trying to be inside the European and American standards. Other questions? No more. Okay, we have very strong agenda today, and let me switch to another